So here, let's see one of the problem which supports applications of linear equations in a pure daily life. So for example, I have a question or a problem which says Snigdha went to a bank to draw rupees 2000. Went to bank to draw rupees 2000. She was given 25 notes of rupees 50 and rupees 100 denomination. Now here, the interesting part of mathematics used is, I wanted to know how many 100 rupees notes and how many 50 rupee notes did Snigdha get from the banker. In the total amount she is drawing was 2000 rupees. So the question here is, how many rupee 50 notes and rupee 100 notes. So how many notes of rupees 50 and rupees 100 notes did Snigdha get from the banker is the question. Now this question is interesting because we come across such situations many a times when we go to the bank or we go to the vegetable vendors to buy some vegetables or to any other shop where we do a lot of shopping through money exchange. And therefore, we need to identify strictly its application in mathematics, especially in linear equations connected to daily life. So let's start with the clear picture of what is given. Totally, Snigdha gets 2000 rupees from the bank. She has been given 25 notes of 50 denomination and 100 denomination. Thirdly, I want to know how many 50 rupee notes and 100 rupee notes did she get from the banker. So initially, I see that total amount Snigdha draws from bank is clearly given to be rupees 2000. But the question here is, we don't know how many 50 rupees notes or how many 100 rupees notes she is getting. So because we don't know the exact picture of the number of 50 and 100 rupees notes in denomination given by the banker, I assume them as X and Y, the unknowns. So here, let X equal to number of rupees 50 notes as given by the banker, and let Y be the number of rupees 100 notes, denomination notes as given by the banker. So here my destination is to find X and Y, which is nothing but finding the solution of the linear equations L1 and L2. So let's see how we can frame the linear equations L1 and L2 using the minimum conditions. Now clearly, as I see here, the number of 50 rupee notes are X and number of 100 rupee notes are Y. So totally, Snigdha is getting 25 notes from the banker, which clearly makes me understand that on the whole, X plus Y is equal to 25, because the total number of notes, the only note she is getting is 50 denomination and 100 denomination. Therefore, the sum of these must be equal to 25, the total number of notes she is receiving by the banker. So clearly, total number of notes Snigdha gets is 25. That implies clearly X plus Y is equal to 25, which is the first linear equation in two variables X and Y I identify from the given problem. Similarly, let's see how the second equation is obtained. So as I clearly see that the total amount she is drawing is 2000 rupees. So total amount being 2000 rupees gives me the clear picture that if there are X notes of 50 rupees which she is receiving, then 50 times of X plus 100 times of Y will be equal to 2000. So therefore I get this equation because I get X is number of 50 rupees notes. So we don't know how many 50 rupees notes are there. So 50 rupee notes taken X times plus 100 rupees notes taken Y times will totally give me the total amount Snigdha is drawing from the banker. So when I add up 50X plus 100Y equal to 2000 is what I get as the second linear equation. But when I further simplify this, I divide with 50 so that I get this is what I get as the linear equation. When I divide the whole equation with 50, I get X plus 2Y equals 40, which is the second linear equation. Now once I get the two equations, solving of these two equations is a choice to the student because the question doesn't mention about whether I had to use the substitution method or the elimination method or the graphical method. So the choice is strictly with me in the method I'm using. So clearly I identify that substitution method is very easy here because the coefficient of X or Y is 1. So remember, substitution method helps only when the coefficients of X or Y is 1. At least one of the coefficients of X or Y is 1, unity. Now because this clearly makes us with coefficient of Y is 1, I think substitution method would be more easier in case of this example problem. So let's see how substitution method can be used to find the values of X and Y. So from 1, if I just say my Y is 25 minus X, because I bring X to the right, it becomes this, is what I get. And substituting this Y in equation 2, then I clearly get X plus 2Y. In place of Y, I have this substituted. 25 minus X is equal to 40 is what I get when I substitute in place of Y as 25 minus X. Now this is reduced to a linear equation in one variable X, which is very easy to simplify. So let's expand with the brackets. That implies X plus 2 times of 25, which is 50, minus 2 times of X minus 2X is 40, which on further simplification gives me X minus 2X is minus X, and 40 plus 50 comes to the right as minus 50 is what I get when I further simplify. Then finally this gets reduced to minus X equals 40 minus 50 is negative 10. Therefore cancelling minus on both sides, I finally get X equal to 10, which in turn gives me the value of Y, because when I substitute X equal to 10 here, I get the value of Y. So this value, when substituted in 1, I get Y equals 25 minus X, which is 10, which is 15. That implies I got the two values, one is X and one is Y, which give us the answer. So therefore, when Snigdha has drawn 2000 rupees, the banker has given her 10 50 rupee notes and 15 100 rupee notes, so that when you add up, you get 2000 on the whole. So therefore, I can say, therefore, Snigdha got 10 rupee 50 notes and 15 rupee 100 notes from banker. From the banker, she got 10 50 rupee notes and 15 100 rupee notes from the banker. When she drew the total amount of 2000 rupees is how we understand the linear equations connected to the real life applications of linear equations using mathematics.